Okay, here we are at the end of the course. I'm Scott Turner.
And I'm Barry Pinchot.
We hope you enjoyed the course and you've learned something from it.
Now that you have a clear theoretical framework for biophysical ecology and you've learned some methods, where can you go from here?
Our emphasis throughout has been on how to think about measurement, how to go beyond simply reporting, say, a temperature, and to give temperature a meaning.
You also learned how to make simple and improvised devices to measure heat and water budgets. Our plaster frogs are a good example.
And so are our copper spheres, and all of the other methods that we've shown you.
As long as you understand the physics beyond the measurements, you can make use of simple methods to put your measurements into meaningful context. But the question still remains, what's next?
How about a field course, where you can apply what you've learned to real-world problems of adaptation and survival in harsh environments?
Which brings us here to the Gobabeb Namib Research Institute in the heart of the Namib Desert, about 90 kilometers southeast of the Namibian port town of Walvis Bay.
Gobabeb has long been a center for desert research. It's situated in one of the world's most interesting deserts, the Namib. To us, the Namib is a pretty harsh-looking place, dominated by sand dunes, stark gravel plains, and occasional coastal fogs, which look ominous to us, but are vital to life in the Namib.
So how do the organisms which live here manage? Well, they adapt. And how do they adapt? Through clever means of controlling heat and water, precisely what we are concerned with in biophysical field methods.
Every year for the last 5 years, we've recruited international groups of students to come to Gobabeb for an intensive hands-on workshop to explore the adaptations of organisms to the Namib environment.
It's no surprise then that our field course is called Biophysical Ecology in the Namib.
We've studied leaf microclimate under the expansive leaves of Namibia's iconic plant, Welwitschia mirabilis.
We have looked at the dynamics of an indigenous plant in the same family as pumpkins and melons, the nara, found in abundance along the course of the ephemeral Kwiseb River. These plants look like desert plants, but they obtain enough water to fill succulent melons, which are an important food source for the local people and animals.
We have examined how ants and beetles manage to stay active on the hot surface of dunes, heated intensely by the subtropical sun.
We also take time to learn about the culture, geology, and natural history of Namibia.
And we spend time discussing science from a broad perspective and learning modern techniques for analyzing data.
Much hard work is involved, but we all have a lot of fun as well. And most participants come away from the experience thinking very differently about the world.
If you think you might be interested in joining our field course in Gobabeb, just drop either of us a line. We try to run an annual expedition, usually in February.
No matter what, we would love to hear from you, what you thought about the online course, as well as any interest you might have in joining us in Namibia.
Alternatively, we can help you set up your own field course in a habitat of your choosing.
The tools you have learned can be applied to any habitat on Earth, whether it be desert, forest, savanna, or polar. The habitats, plants, and animals might differ, but the physics will be the same everywhere.
We'll be happy to share with you our own experiences in course organization, how to frame questions and discussions, and ways to make your own course rich, inspiring, and fun.
We might even be able to work together on developing your own course. In any case, please drop us a line.
Thanks again for your interest in biophysical field methods.